Welcome to Vidyotma Physics. In this lecture, I'm going to explain you about concept of electric flux and then we will solve some numericals based on that. First, whenever this word flux comes in your mind, you should remember your lunch break in the school. Why, sir? Just before lunch break, when there was a bell, what you used to do? So you used to run perpendicular to the door, along the door, yes or no? So this is door and you used to run in this way. So number of students which are running through the door is nothing but flux of that students. What I'm saying is, what flux calculates is number of field lines perpendicular to surface. Let me explain. So student flux, if I want to say, so number of students passing along the door. So this is door and this is perpendicular direction. Let us take example. So this is our cylindrical surface and electric field is along the axis of cylinder, right? So where is the area vector? So here first you understand area. So this is our area. Okay, sir. Can you see the electric field lines are perpendicular to this area? So whenever I write flux, I will say number of electric field lines perpendicular to area. Very simple concept. It is denoted by phi. Sir, is there any formula? Yes, there must be one formula, right? Now, this flux must be directly proportional to electric field. Sir, why? Because if electric field is more, then number of field lines will be more. As simple as that. Yes or no? Yes, sir. Then this flux should also directly proportional to area. Why? Because as area increases, number of field lines should increase. How, sir? See, here, if you increase the area, can you see that number of field lines are increasing? Yes. So extra field lines are now passing. Correct? Very good. Now, what else? So flux depends on electric field and area, that we understood, sir. Is there any other thing on which flux is dependent? Yes, there is. Orientation. Orientation also flux depends. How? Let me explain. So let us say this is an area. So this area is which plane? So this is XZ plane. Okay. And our electric field lines are cutting like this. So what I told just now, flux is nothing but number of electric field lines perpendicular to the area or perpendicular to the surface. Now you tell me, we cannot take these field lines directly. Why, sir? Because they are not perpendicular to this surface. So what we have to do is, we have to resolve them. How to resolve? So if I resolve, so two components will be there. One will be perpendicular to the surface and another will be what? Along to the surface. And this component which is perpendicular to the surface is only responsible for flux. And this which is along the surface is not responsible. But then how to count such perpendicular lines? For that, what we do is, we define area vector for this surface. So where is the area vector? Area vector is perpendicular to this surface. And if we resolve electric field along this area vector, then we get number of electric field lines perpendicular to that surface. What I mean? So if I resolve this, so this component is what? E cos theta, correct? And this is E sin theta. So actually, this electric flux is not proportional to E, but in fact it is proportional to E cos theta. Why E cos theta? Because we want perpendicular component of electric field. So therefore, what my final formula comes? So final formula is simply product of EA cos theta. This is formula for electric flux. Are you getting it? Three factors it depends. First, electrical field intensity, E, then area, and then orientation or cos theta. Now let me explain. Another important formula flux is integration. Sir, why integration is used? I will tell you. Look here. Here, if I want to calculate flux through this surface, okay, or number of electric field lines perpendicular to this surface, whatever. So here, if you see, this is a sphere, okay, this is a solid sphere. So if I take area vector, so area vector, how I will take? Let us say this is our area, this is area, this is area. Okay, if I draw tangent, area vector is always perpendicular to the surface. Okay, for orientation calculation we take. So where is our area vector now? This is our area vector. Here if I draw tangent, so area vector is like this. Okay sir. Here if I draw tangent, my area vector is like this. Can you see that the angle between area vector, and electric field, let us say this is theta 1 and this is theta 2, this is theta 3. That means angles are different. And if I want to calculate flux associated with the total surface, how I can do that? It's difficult, right? So what we write is, essentially what we write is, we write that total flux is equal to, let us say, not only angle, electric field is also different. Okay, so what we write, sir, E1 or small area is dA, let us say, cos theta 1 plus E2 dA cos theta 2 plus dot dot dot. Many areas you have to take and many cos theta, or entire surface of the sphere you have to take. So there is a continuous addition. So continuous addition is nothing but what? It is simply I write flux is nothing but integration of E ds, or let us say E dA cos theta. Okay, or I can also write it as integration of E dA cos theta or EA cos theta. What is the formula? Dot product. Yes. So flux is what? Sir, flux is dot product of electric field and area vector. Simple. So E dot dA. This is another formula for flux. When to use integration? When we cannot calculate directly. Here it was not necessary. Why not necessary, sir? Because angle between electric field and area vector was same everywhere, and electric field was also uniform. But here that is not the case because angle is changing, so I have applied integration. One more thing, are you able to visualize that this is the dot product, right? And electric flux is number of field lines perpendicular to the area. So if the number is there, that means this is a scalar quantity. We'll look more into the properties. And here are important properties, okay, of electric flux. What is that? Number of field lines is electric flux, that you understood. It is a scalar quantity. Why scalar quantity? Anyway, it is a dot product of electric field and area vector, and dot product is a scalar quantity. Very good. Okay. Sir, area vector, very important. You must know about area vector. Basically, for orientation, two bodies are there. One is 2D, another is 3D. 2D means, so let us say this is a disc kind of thing and this is a sphere. Now you tell me which area vector is correct. This area vector is correct or this area vector is correct? What I told regarding area vector, that area vector is perpendicular to the surface. So this is the surface. So this is also perpendicular, this is also perpendicular. So in this case, I will say both areas are correct. For 2D surface, you can take area anywhere, area vector anywhere, either upside or downside, or just it should be perpendicular to the surface, that's it. But when it comes to 3D vector, okay, when it comes to 3D bodies, always remember that we take area vector outside the surface. It is perpendicular to the surface, no problem, okay. So this is a perpendicular 90-degree angle. Here also it is a perpendicular 90-degree angle, but it should always be outside the surface. Okay, very good. So formula just we have seen. So I told you that when to use this formula, EA cos theta directly. When we will use this? When uniform electric field is there. Uniform electric field means electric field is same everywhere in direction as well as magnitude. Okay. And angle should also be same. So see, this is example. Electric field was uniform, direction is also same, and magnitude is also same. Even electric field is making same angle with all area vectors over here. Are you getting it? If I draw area vector, still you will get same angle. If I draw here also area vector, still you will get same angle. So in this case, directly use that formula. And when integration is used, so integration is simply used when electric field is non-uniform. If electric field value is changing at every point, so I cannot write the same electric field for all points. So I have to then write as E1 dA1 cos theta 1 plus E2 dA2 cos theta 2. That is nothing but integration. Fine. And different theta, as I have explained previously. So you tell me here, integration should be used or not? Tell me. Is there necessity of integration? No. Why? because electric field line is what? Uniform, and angle with area is also same. Can you see that? So no integration. Which formula I will use? Simply EA cos theta. Very good. Okay. What about this, sir? Here electric field is uniform. Okay. Uniform electric field is there. But there is one problem. What problem is there? That angle is different. Angle is not same for every, see, here, where is my area vector? This is area vector. Fine. Let us say this is angle theta 1. Now if you see this, okay, where is area vector for this curved surface? This is area vector. And let us say this angle is theta 2. It is different, correct? If I see area vector over here, it is a curved, okay? It is a curved surface like this. So here area vector is like this, and where is your field? It is like this, okay? So angle is again different. So angle is different, therefore integration formula should be used. That is EDA cos theta. Are you getting it? Both conditions should be satisfied. If you want to use this formula, both conditions should be satisfied. Angle should also be same and electric field should also be uniform. Very good. Let us see next property. What is next property? So incoming flux, whenever you write, actually flux has no direction because it is a scalar quantity, okay? But whenever lines are going inside the surface, we take flux as negative, and when they are coming outside, we take flux as positive, okay? So in this diagram, if I want to write flux, so this side which is coming outside, electric field are coming outside, this is positive and this is what? Negative. Let me write what is the flux, sir? Total flux. So here can I write total flux as inside plus outside? Perfectly. I can write it. What is the problem? No problem at all. Okay. So line comings inward plus line goings outward. Now you tell me one thing. What was flux? Number of field lines passing through area. Can you see that? 1, 2, 3. Here 3 lines are entering, and here how many lines are leaving? So 3 lines are leaving. So if I say that, let us assume inside flux and outside flux. So outside, if flux is x means it is a number, okay, number. So inside will be minus x, just equal in magnitude, but in sign it is just negative. Why equal, sir? Because number of field lines passing are same. So if I write, what I will get? Minus x plus x, which is equal to how much? 0. One thing you should note here. What is that one thing, or 5-star point? What is that point? I will write here that whenever in a uniform electric field, what I'm saying, in a uniform electric field for closed surface, flux is always 0. Let me write. Uniform electric field for closed surface. For closed surface, flux is always 0. Always remember this, because this can be asked as a MCQ in exam. Are you getting it? What I'm trying to say? Uniform electric field means again same in magnitude and direction. So this is a kind of uniform electric field. So this is a closed surface. Solid sphere is a closed surface. So what is flux? It is 0. Why it is 0? Because number of field lines which are coming and going, they are same. Let us take this example. Here, can you tell me, this is again a solid sphere, can you tell me what is flux through this surface? So answer is what? Yes, answer is 0 here. Sir, here flux is equal to 0. Why 0? You tell me. Actually flux is 0 because here positive charge, if I take positive charge, let us say, so positive charge field will be outside, right? And since positive charge is equal in magnitude for as negative charge, so whatever number of field lines are outside, going outside, the same number of field lines will come inside. Are you getting it? So number of field lines going out and coming in are same. So here, what is the flux? 0. I will tell you one important point which you will learn in Gauss law. What is that important point? That if charge inside closed surface is equal to 0, then flux is 0. Always remember. Inside a closed surface is charge is 0, then flux is what? 0. 100%, 200%, 1000%. Are you getting it what I'm trying to say? Here you tell me what is charge here? Sir, Q and minus Q. What is total charge? 0. So here what should be the flux? 0. Another important thing. Can you tell me, let us say here flux is phi1 and here flux is phi2. Can you tell me phi1 is greater or phi2 is greater? Sir, it appears as phi1 is greater, sir, or phi2. Here plus Q is kept near to the surface and here center of the sphere. Both are inside, okay? So here if I want to draw the field lines, how it will be? Let us say these are the field lines, sir. Perfectly fine. Here if I want to draw the field lines, then these are the field lines. You tell me which field line is more, first or second? Both field lines are same. Why? Because magnitude of charge is what? Same. Go to the basics. Field line depend on what? Charge, right? Higher is the charge in magnitude, the more are the number of field lines. So here number of field lines are not changing. Field orientation may be different. Are you getting it what I'm trying to say? See, one thing it should be very conceptually clear to you. What? That field at this point and this point is different for both the charges. Okay, so field if I compare for this point and this point, so here field will be different and here field will be different, but for flux what matters is number of field lines crossing perpendicular to the area. So number of field lines are same here, so what I will say, phi1 is equal to what? Phi2. One more important point I get, that inside closed surface, location of charge is not important. So no matter where I keep charge inside, okay, flux will be same. Are you getting it? Three things important we have learned here. What is number one? So number one is in a uniform electric field, if there is a closed surface, always flux is 0. If there is no charge, no net charge inside the closed surface, flux is 0. And third, the location of charge does not matter for calculation of flux inside a closed surface. These are things you are going to learn in Gauss law. Are you getting it? Okay, very good. Let's try and solve some numerical. Are you ready? Yes, sir, we are ready. Let's see. So here, find flux. So tell me, what is the flux? What is the formula? So here the formula is what? Phi is equal to simply EA cos theta, because it is a uniform electric field and theta is also same. Now by now you are very brilliant. Okay, very good. What is theta here? Sir, 30 degree. No, it's not 30 degree. 30 is given here, but which angle we take? Angle between area vector. Where is area vector? This is our area vector. Area vector and field line. So what is this angle? This is 60 degree. Are you getting it? So simply substitute here. What is E? Sir, 20, 10 cos 60. Whatever is the answer. Okay, so 200 and 1 by 2. How much it is? 100. And what will be units? By the way, what is unit for flux? So unit is simply Newton per Coulomb and meter square. Okay, anyway, that unit, dimension, etc., that are basic things that you can do. Now here you tell me, so here our loop is in XY plane. XY plane, you understand, the plane of the board, and these are the electric field lines given. This question was asked in AIPMT. Okay, now you tell me what is flux here. Can I write here EA cos 37? Can I write or I can't? Absolutely I cannot write. Why cannot write? Because here angle is not 37. Sir, so is angle our 53? No, angle is also not 53. Angle does not matter. What matters is how the area vector is. You tell me this is in XY plane. So where is area? For 2D body, area vector is perpendicular to the surface, right? So this is my area vector. My hand is area vector. So what is angle between my hand and this electric field? My hand is in which plane? It is in XZ plane, and this is in what? XY plane. So angle is how much? 90 degree. So here theta is 90 degree. So what is flux, sir? So flux is what? 0. If theta is 90 degree, cos 90 is how much? 0. Okay, very good. What about this? So here it is a cylindrical surface, uniform electric field is given, and you need to find 4 things: total flux, incoming flux, outgoing flux, curved surface flux. Are you ready? Try it yourself, then I will tell. Tried? Now I will tell. Total flux, which property should you use? What I told, in a uniform electric field for a closed surface, what is the total flux? 0. Yes or no? This is a closed surface. Yes sir, cylinder is a closed surface, so total flux is what? 0. Are you getting it? Yes sir. Incoming means, where is incoming flux? This is incoming flux. So for incoming, what I write? First you tell me what is area. Let me mark area vector, else you will do some mistake. Area vector for a 3D body, cylinder is a 3D body, is always outside. Very good. So where is area vector? Sir, this is our area vector here. I will write area vector, will denote by n cap. Okay, here also the area vector is like this, n cap. And sir, for curved surface, how is the area? So this is area. For curved surface, area vector will look like this. Okay, now you tell me one thing, that what should be the answer? Here area vector, what is angle between area vector and electric field? 180 degree. Can you see? And anyway angle does not matter. What I told, incoming flux should be negative, so flux should be negative. So what I will write? Sir, E, and what is this area? Area is how much? Area is pi r square. Very good, pi r square. Okay, and this is in negative. Are you getting it? Cos 180, anyway it is -1. Sir, what about this? It is how much? It is simply positive, E pi r square. Because angle is how much now? 0 degree, or anyway it is outward, so you will take positive. Sir, what about curved surface? You tell me about curved surface. What is angle? By the way, what is angle between fields? Sir, where is field line here? Can you see the electric field line? I can see. Why you can't? See, where is electric field line? This is electric field line. And what is this angle? 90 degree. So if angle is 90 degree, what is flux? Sir, 0. For angle 90 degree, why it is answer is because angle is how much? 90 degree. Is it easy? Yes, it is very easy. So I have not discussed any technical thing. Okay, on surface level we are going, and yes, many questions are solved on the basis of this. Can you tell me this? I want total flux, and I want curved surface flux. Total, anyway you can tell it is a closed surface, 100% is a closed surface. So for closed surface, what is the flux? Is equal to 0 in a uniform electric field. Always remember. Okay. Okay. What about the curved surface? Now this is a good question. See one thing. Here I cannot write that for curved surface. Sir, what is area? By the way, hemisphere curved surface area is 2 pi r square. Can I write flux as electric field into 2 pi r square? I cannot write. Why I cannot write? Because you understand one thing, that area angle is changing here. See sir, angle is not same. Can you see that? Everywhere my angle, let us say here it is θ1, here it is θ2, and here it is θ3. So angle is not changing, so how I can write same angle for everything? I cannot write. Okay, so this you cannot write. So what? Because for this curved surface you cannot write formula directly. So sir, should we do integration? We are not that intelligent to do integration. Okay, it is not possible also in this case. So here what we will do is we will apply some logic. What kind of logic? We know that total flux is 0. See, total, what is phi total? Total is nothing but incoming plus outgoing. Yes or no? Yes sir. So total anyway is 0. Can you tell me what is incoming flux? Sir, incoming flux we anyway write in negative. Where is incoming? This circular area. This area is having incoming flux. Are you getting it? Okay sir. What is area of this? Simply pi r square. It is a circular, right? Circular surface. So I will write electric field into pi r square. Already I have declared negative. Don't write double negative. Okay. Plus phi outside. So from here you will get phi outside as E into pi r square. That's it. So all the best.